Hello everyone and welcome to Rebel Way. My name's Andrew Sutherland and today we're going to be taking a look at this melting bottle effect. So we have this metal sphere which has been heated up and that's going to land on the bottle's going to melt, the liquid's going to shoot out, and of course we're going to have some smoke. So let's take a look at how I created this. And the first things first is I found that for this very high viscosity sort of melting of the bottle, I found that actually flip fluids was the best way to go for that. And for the small scale water splashes, I used vellum fluids for that. And let's just dive in and take a look. So this bottle I got from online. I will share the link. Let me actually just find that. So I downloaded this free bottle and this is what I used in the scene. So I'm just loading in the bottle. I'm transforming it up because they sort of say in Houdini you simulate at real world scales, but with smaller objects I find that's not the case. It's much better to just scale these things up, work on them at a larger scale, and then scale them back down when you want to send them to, let's say, a render department or anything like that. So just in my scene, I've got this scaled up quite a bit. I'm deleting the cap and I'm deleting the label. And here I am clipping just the very top, because you can see that this is actually, a double-sided mesh. And what I want is I just want this outside part. So I'm going to blast this inside part. I just came over here and I double clicked and hit delete on my keyboard, and that's going to delete the inside part. From there I can put down a null, which we're going to read in later. And as you can see now, we just have this outside of our mesh. From there I just wanted to recompute the normals, subdivide, and subdivide again. So now we have a higher resolution mesh. From here I was just clipping off the top and I was creating a polyfill, normal, VDB, convert. I just peek this inwards a bit, VDB'd again, and this is just some collisions. I suppose to make this a little bit better, I should have put down a VDB from polygons. Convert, VDB convert. And this would be a little bit better because you see this peak has created some issues there. So just converting this into VDB is going to clear up little issues like that, and you should have a pretty good mesh to work with. Coming out here, we've got a bottle, just the outside part. We're going to put down a null that we can read in again, and here I'm going to scatter some points. So the idea here was kind of to have almost like this is the liquid, and I don't want my bottle to just melt and fall down inside here, because in the reference I was looking at, we had a bottle and it was filled with some sort of soft drink, and I didn't want it to just all the plastic to fall in. I wanted it to sort of fall outwards, and that's why I've created this collision here. It can fall down a bit at the top, and then I wanted it to sort of melt outwards. So from there I've got the bottle and I'm going to scatter just some points. If we take a look at my scatter, you can see we have 200,000 points, and for what I'm going to do there is I'm going to create a very high viscosity value on those points. So as you can see here, our points have position and viscosity. These are the two attributes that are important in this case. And what I want to do is I want to create some sort of growth and change the viscosity value as that growth grows across this bottle. So there's two sort of ways I thought of doing this. The one is just to take a sphere, scatter some points on it, and set a viscosity of 0, and then move that sphere down this bottle and transfer that viscosity value from the sphere points onto the bottle. So basically just override that viscosity value. And we could do this so many ways in Houdini, but I thought the easiest way for someone who's new to Houdini would just to attribute transfer. So I once did a tutorial on a volcano, and in that scene we did very similar tricks, but it was all done through Vex, and it could have seemed a bit complicated for a beginner to Houdini. And the concept really is not very different. You know, the attribute transfer node in Houdini, all it's doing is it's looking up the nearest points, and you just transfer data like that. So we could have done that in Vex like we did in the volcano tutorial by using the near point function. But for this, I thought I should show how to just simply attribute transfer and overwrite attributes, because it's really extremely powerful. Even if you're a beginner and you don't know much about Houdini, just being able to transfer attributes from one object to another means you could do so many different cool effects. And so in this case here, I am using a growth solver, so we'll take a look at that, but let's just briefly just take a look at this. So these points all have this viscosity value of 10 or 100,000. And what we could do is we could just put down a sphere. Let's move this up. And just to be absolutely clear, let's just scatter points on it. So we have points there, and we have points on our bottle. So just for clarity, let's put down a color node. And let's set this to red, since we've got a high value of viscosity. So let's represent that by this red color. So forget that we're using viscosity. In this case, just to illustrate, we're going to use color. So we've got red, and on this one, I'm going to make this blue. Cool. And then if we put down an attribute transfer, what I want to do is I want to transfer this blue color onto these red points. So here they are red, and here our sphere is blue, and once we attribute transfer, everything's going to jump to blue. And the reason for that is that we need to come over to these conditions, and we just need to dial this down a bit. And as you can see now, it's only affecting this radius. So basically the points here are looking up the distance from these points to these points, and it's going to transfer the attribute based on that distance. So as you can see that here. So I'm going to make this quite low. We can fade this out with this blend. And then if I were to animate this, you can see our attributes are being transferred, and this is very, very powerful. You can use this in so many different ways. You can see here it's getting a bit lower because our distance, it's gotten thicker, so we can just increase this. And I often use color just to visualize things. So, in this case we have color, so let's remove the color, and instead let's use viscosity. So we've got viscosity on here, and let's add a viscosity value of 0 on here. And now it's actually doing the same thing, but we can't see it because obviously viscosity is not something we can see until we run it into a simulation. But what I can do is I can put down a color here, and I can say ramp from attribute, and then I can just visualize the viscosity. And like we had before, let's make this blue, and let's make this red. And remember, we had a very high value, so we need to put a high value in here, and now we can see it like we had before. So now we're just visualizing the viscosity. We're not transferring color, we're literally just transferring the viscosity, and the exact same thing works like before, where we move this up and down. So with that in mind, let's take a look at what I did here. So we're going to do something very similar. And in this case, we're importing those points. And we're going to group these very top points. And we're going to create an attribute called temperature. And the reason we're doing this is that we're going to use this Pyro source spread. And this requires a temperature to start. So some of those points have temperature, and once we feed this in, we can see, so you can see these are all blued out. And the reason that we've actually, this is actually a reference copy from a version that I'm doing inside the DOP network, because I actually want to do this process inside the DOP network. But for now, for visualization purposes, let's just take a look at it out here in SOPs. It's going to be easier that way. So here, we're actually transferring this burning growth here. So you can see, I need to visualize it like we did before. So here I'm visualizing the temperature. And I could actually make this a little bit more interesting. Could say infrared. And so now this is our temperature. These are our hot points and this is our cold points. And what we're going to do is we could like rename this temperature to viscosity, and we could have this growth changing the viscosity value on our points here, which will then be fed into our simulation. So in this case, actually I need this to be black and white. Let's just delete this. Let's just go back. So this is where our simulation is going to take place, and we're going to do this inside DOPS. But what I wanted to do is I also wanted to push our melting plastic outwards a bit. So what I did is I deleted everything except for this melted part, because this is the part that's going to melt. And then using this match size node, I can set this to min, and I can take the sphere, it's the same sort of sphere that we're going to use as our collision geometry, while our sort of metal ball that's going to melt. And I wanted it to move downwards as it melted. And in order to do that and have the exact same position, is I use this match size node. And you can see that this is reading the minimum of this. So it's going to look at the very bottom of this point so it's going to look at the very bottom of this melting part, and it's going to place our sphere there. So now without animating this ball manually, it's just going to animate itself as this melts. And then I just transformed it down a bit. Well, actually I'm not. I think I experimented with moving this position, but I'm not using that. And I've got an out sphere. And here I also just noised it up because I didn't want it to melt the plastic perfectly. I wanted it sort of push plastic out in this sort of more organic-y looking shape. So that's why I've just put some noise on here. It's set to 0 centered, and we have some animation on that sphere. So we're going to use that as some collision geometry. And again, like I showed before, we're just going to create a VDB. We'll create a surface and we tick in fill interior, and we're going to put an out collision SDF, and here's our geometry. So we've got a VDB version and a geometry version. You can ignore this. I was just taking a look at different timings, experimenting with different, how far I wanted it to go. And because I didn't want to render too many frames, I decided I'll just have it melt up until this label and then stop. But, by all means, experiment with this. You could, melt the entire bottle. That might look pretty cool. But for to keep things light and to get through this tutorial quickly, I'm just going to melt half the bottle. So from there, I've got this DOP network. So let's dive into this DOP network and we can take a look at what we've got here. So first things first, obviously the most important thing that we need in every flip simulation is this flip object, this flip solver, and we usually have a volume source, something to bring in the data. But in this case, we're actually using a SOP solver, because what we're going to do is we're going to bring in the information from the DOP network using the DOP import. And here we've got two versions that we can take a look at. The one version I'm not using is the simple attribute transfer that we looked at, where we have the sphere. We're noising it up a bit. We're putting points here, and we're creating that viscosity of 0. And on here we have a viscosity, and here we're overwriting that viscosity attribute. So we're pulling in the data here with the viscosity, and we're overwriting it with this one using this attribute transfer, and then we're just blurring it. And so if we put down a color, we could take a look at what's happening with the viscosity. We say attribute from ramp, and we say viscosity, and let's just make this something like this. And as you can see here, this is our viscosity being changed. But I didn't end up using this version. You can experiment with this. You'd obviously maybe need to increase this distance. Yeah, something like that. In this case, I used that growth solve idea. So bringing in the data, we're creating a start group, we're creating the temperature, we're using that Pyro process, and this is exact copy of the one out here. I actually did it first in the DOP network, and then I thought I should show it outside here so we can see what's going on a little bit simpler. So it's the exact same thing. In fact, it's literally just a copy of that, and you can see that that's what I'm doing here. And here I'm transferring this viscosity. So we're using this bind import. We're bringing in the viscosity, and we're taking the data from the second input. Yeah, so we're taking in this thing, and then we're taking in the second input here, the temperature. We're fitting this between, because it has a value between 0 and 10, and we're just fitting it between 1 and 0. So it's being negated. It's reversed. This is normally 0 and this is normally 1, but we're negating that. And then we're multiplying it with the viscosity and just re-exporting it. And that's going to use the temperature as a mask. So this viscosity is being masked out by the temperature. Because obviously if the temperature is 0 and we multiply whatever the value is, so let's say the value is 10,000, 10,000 times by 0 is going to result in a viscosity of 0. But where there's temperature, let's say a temperature of 1, so 1 times 10,000 is going to be 10,000. So the viscosity there is going to be 10,000. And of course, we can just visualize that. And as you can see here, so where there's no viscosity, it's going to melt. And where there is viscosity, it's going to remain solid. And we just have our out. The other thing I added is, so we've got some pop drag here. And it's quite a high resistance, just so that this doesn't just fall down like a liquid. I actually wanted to just sort of remain there, and it's going to be pushed aside by our collision. So our collision here is we're reading in that sphere, and we're reading the geometry here, and then we've set this to use volume collisions. Set to volume sample, and then we're going to paste our SDF version. So the VDB version goes in here, and our geometry version goes in here. And I just find that this is the most accurate way to get collisions. And of course, our collisions are changing shape, so we need to take on use deforming geometry. And the other thing here is the inside of this bottle, because like I said, I didn't want this just to simply fall down. I wanted it to be pushed out. So we're reading in that bottle geometry that you see here. So there and that, and put that all together, and now we're going to have a simulation like this. From there, all we need to do is import our simulation, and you can see you can just come here and you can say liquid, and all I'm really caching is the geometry, surface, and velocity. We're reading in this network like that, and we're reading in this flip object, so you can copy this and paste that here. Let's just take a look at our flip settings. we need to make sure that reseeding is turned off, I should say, because when we reseed, we introducing new particles every frame. We don't want that. We want this to accumulate because we're using the SOP solver. So reseed is turned off. And I was experimenting with the vorticity just to change the color of this, but I didn't end up using this. I ended up just using, I believe, the velocity. Or did I think I just may have just used the, I'll take a look at what I ended up using. I tried a few things. Can't remember exactly what I resulted on, but I think I used I think I actually just straight up used the viscosity value. Nothing crazy here. I don't think I changed the substeps, did I? Nope. This is our volume limits, obviously. I could have made this even smaller because it's not really splashing around or moving much, you know, so if you want, you can make this even smaller. And just make sure that we have our box in the middle. Like I said, pop drag with air resistance because I didn't really want this to drip down or move much at all. I just wanted it to sort of like look as if it's melting and then sort of solidifying again, and I got that effect by just increasing this air resistance pretty high. I did multiply the density up a bit. I sometimes do this when I scale up a simulation. Say, you know, let's say you've got a liquid simulation and you've scaled it up 3 times or 10 times. Sometimes increasing your gravity can compensate for that scaling up of a scene. In this case, I don't think I actually even needed to do that, because at the end of the day, I ended up putting so much air resistance it wasn't really moving much at all. But I did this while I was experimenting, and I just kind of left it there. But something to keep in mind when you are scaling things up, let's say you do, you scale up your destruction, which sometimes I do. You then might also want to think about increasing your gravity. It's something you need to experiment with. By no means saying always do that, or, you know, I think it comes down to whatever works in the situation. Look at your reference, try and match the motion in your reference, always use reference wherever you can, and that's going to tell you whether it's right or not. You know, sometimes you get comments like, why do you do this? Why do you do that? Well, I don't believe that there is a one perfect way to doing things. I like to experiment. I like to try different things. And if you've got a reference side by side, try and match that reference as best as possible. And if you're working at small scale and, you know, Houdini battles to work at that scale, scale it up. But then understand that it's not going to be physically accurate, and you need to compensate for things based on your reference. And that's what I was doing here. I didn't end up, this is probably not really doing anything in the scene, like I said, because of this air resistance. Okay, let's jump back, and you can see, like I said, this is cached out. And I just wanted to keep the points, so I'm blasting all the primitives. And here I'm using this compress node. You can see that this has been read from our particle simulation here. So that's a copy of that. And you can see these are all my attributes. So from there, I just cached this out to disk. I wanted to save it at this point. And in order to visualize it again, I put down a particle fluid surface. From here, I came over to surface polygon soup. The soup is just a little bit lighter than the polygons, so I used that. And then I unpacked this here, and I colored based on the viscosity. And I just used a value of white. And then I wanted this to sort of as this melts, I wanted the bottle sort of to caramelize, or you know how when plastic melts, it sort of becomes that sort of like orangey brown color. So that's why I'm coloring it like this. And then I just wanted to transfer that color onto my primitives. So once again, I'm illustrating how you can use an attribute transfer, because that I think is the point of this tutorial. Use this node, you know, it's very, very powerful. It's very, very powerful, and you can do so many cool effects with this. So here I'm just transferring the color and the velocity onto this primitive. So you can see this is sort of not melting now, and now we've got this nice color. From there, I'm just blurring this out a bit, because you know here it was a bit jagged, so we can get this nice transition like that. Now I'm deleting everything except for the position, velocity, and color, and I save that to disk. And I put a null that we can read in for render. And that is that for our melting plastic. You can see how this is happening. You can see it's not falling in because we had that geometry there, and we are pushing this out. We do have a few floating pieces here. I couldn't see that because I was at the back there. But what we could do for that is that we have this labs. The labs delete small pieces, so you can say labs delete small parts. And you can see it's not working. And if we click on here, you can see our primitives are like packed. So what we can do is we can just say convert. And this is going to convert this into geometry. It's going to convert this into polygons, because I think we had that as polygon soup. So now we actually want the polygons. So we can see we now have our primitives here, and this is now in fact working. So we can delete those little small pieces. Perfect. Over here, I've got the label, and I just made this in Photoshop quickly. And all it is I'm reading the bottle, and I pasted this section. So we have the exact same size, and I'm just blasting everything but this label. This has a name, computing the normals, so dividing somebody, and here I'm just putting some UVs, and I was offsetting it. This means that I can just, so like for instance here, I'm loading in this texture, and if I offset it, I can just control the placement. And I squished it a bit, just because it looked better. And coming up over here, we can see we're reading in the melted bottle, the mesh, which is coming from here. So I'm just using an object merge. An object merge just means that we can copy paste the link. So copying that null, paste it in there. And here I'm adding a tube. And the reason for this is that I want to drop that ball, and I don't want it to hit here and potentially fall out. I wanted it to sit on top here like it's, you know, melting this and it's sticking a bit. And I figured the easiest way to do that is to just constrain where it can actually fall. So you can see it's got nowhere to go but down. So I just merged those two together, created a VDB version. So this is our VDB version, and this is our mesh version. And it's very low res because we're not going to see this. It doesn't matter. I just want it to be fast. And from here, I'm preparing our sphere. I'm transforming this up, and I'm creating this noise on it. You can see, so this is just, you know, swimming through this noise. And the reason for that is that I wanted some variation for the color. And from there, I just packed this. So using this assemble node, we need to pack this in order to feed this over to a DOP simulation, because the DOP simulation just wants a point and the radius of this so that it knows how to calculate. And so with that, this is like as simple as it's ever going to get for an RBD simulation. We're just reading in that packed object. As you can see, here's the VDB ball. You can see I'm visualizing the geometry here. Yeah, it doesn't really matter. So as you can see, we've got this packed object, and here we have our collisions. And you can see I'm displaying the volume and the geometry. And let's turn this off just so we can see. And we're putting this into an RBD solver. I don't think I changed anything. It was so basic. I just, fed this in, RBD solver, gravity, and out. And you can see this is just gonna go and it's gonna sit on top of our collision. So let's maybe jump outside. Let's just take a look at our melted bit. Yeah. So as you can see here, as this melts, this ball is just sitting on top of here, and obviously it can't roll anywhere because of that constraint that not constraint, but that geometry that we put here. And here I'm just transforming this down a bit. I wanted it to sit inside. I didn't want it to sit on top perfectly. I wanted it to just be a little bit inside this melting part. From here I can unpack it because we had a packed geometry. I had a rest because I was going to play with noise in the shader, but I don't think I used that. So use it, don't use it, it's fine. But we have a rest attribute if we want to do some shading. And then this out. If we take a look at what we've got so far, let's just disconnect these two that we haven't looked at yet. But you can see now this ball is sitting here and it's melting this, and it all feels like it's all integrated. It is intersecting a bit with our melting part, but that doesn't matter. Once we have the smoke and everything, it's going to look really good. Cool. So that's all I did there. From here, we're preparing collisions once again. And I'm actually just deleting this. So we've got this sphere, I'm unpacking it. Mounting this up so it's a bit noisy. And I'm just going to delete this. And the main reason I did this is I wanted some gaps between the ball and our bottle, so that once we fill this with liquid, it has some space to shoot out. So if we take a look at this, yeah, you can see we've now got some gaps. I mean, there always were some gaps, but I wanted just to have a bit more. So let me see, let's just take a look. Yeah, so I just wanted a bit more gaps in between here. And we're going to use that or something similar for when we do the fluid simulation. But let's just take a look over here quickly. This is preparing the smoke. So all I did is I put down a pyro source, and I think, I'm not sure if I actually even used this. I think I may have just set up, let me just try source smoke. Yeah, I came over to source smoke, and we got a density and a temperature. Yeah, density and temperature. And I didn't really change anything. Like, I have no noises. It's just, everything is emitting smoke, this whole sphere. And you can see I've got that on these points. And from here, if we take a look at our velocity, you can see, maybe that's too much. Let me take a look at this rather. I'm going to press D on my keyboard and just change the background to dark. Hide our grid. And all I'm doing here is I'm using this curl noise. So as you can see before, I've added this velocity, which is going to give it an upward movement. So without this, we've got no velocity. Now we've got a bit of an upward movement, and then I've introduced some curl noise. And as you can see, we can sort of tweak this. And based on my reference I was looking at, I just wanted it to sort of swirl around and push smoke out. Every now and then some would shoot out down the bottom. So I didn't want it just going up like that. I also wanted it to shoot out a bit. And so these are my settings I dialed in. I don't think I changed anything here. Nope, just that. And from there, obviously these are points. And in order to pass this over to a stop simulation for smoke, we need to rasterize those points and make them VDBs or volumes. So as you can see here, we're now turning the density, temperature, and velocity into volumes. And this is, it doesn't look nice because we are layering the velocity, temperature, and density. If we wanted to just look at the density, we could put down like a volume visualization. And we could look at specifically just the density, or we could put down a visualize node. So now we said we're hiding the temperature and we're hiding the velocity, so we're looking at just the density. Yeah, so let's just set this to hide and say temperature and velocity and visualize, and we hide that, and it's the same as this really. Yeah, so these are our fields, density, temperature, velocity, and we're going to pass that over to our smoke simulation. So here, of course, we need three main things: smoke object, smoke solver, and a volume source. And here you can see we're bringing in the source. So we're just reading in this node, copy that, come over here, paste, you can click on initialize, and sometimes you have to click off, so you know you can. Let me just check my values first before I change anything. So let's change back, and this is all set up. And what I probably should have done in this is, as my ball, as the sphere cools off, we could just animate the velocity down, or the temperature and the density. I'll probably go to the velocity and the temperature. I'll probably go to the velocity and the density and just animate that value down over time. So the smoke will sort of chill out and dissipate more as the ball cools down. I didn't do that in this scene, but I would certainly go back and add that. And the other thing is I actually used this as collision. So using it, you could do a static object like we did in the previous DOP networks and just read it in as a VDB and geometry. But instead here, I just used the VDB. So this, I called pig already because I was doing some tests. So we want the smoke to collide with this. So I'm just preparing this as a bottle SDF call. And we're going to read that in this node as SDF, and we're going to set this to collision. And you can see this is reading in, well, it wants collision, but I don't think we have that now. If I change this back, you can see I had surface here, because when we convert this to VDB, it creates this distance VDB and it's called surface. So what we could do is we could just change the name here to collision, but instead of doing that, I came over here and I just changed this collision to surface. So now it's reading in this field and it's targeting collision, and it's set to -1, and that's going to set up our collisions. The only other thing that we need to do is we need to come down here to collisions, and I think by default this goes, let me just take a look at how this looks by default. Come over to advanced, come over to collisions, and you can see this is how it comes by default, and I've unticked this. And that is going to ensure that this setup works nicely. If you don't want to use this, you can use the static object, but actually this is the most efficient way to do collisions in Pyro. So I've done it that way. Let's just take a look at all our settings. Yeah, I changed this to BFCC and clamps. This gives us a bit more detail. I actually find maybe I'm getting a bit too much detail in this point. This Matt McCormick, I dialed in my microsolvers like that, and then just before I summed the high res, I changed it to BFCC. But I think it might actually look even better with just this, with the details toned down a little bit. Yeah. So talking of our shape, I don't think I changed anything here. I think I kept this all default, and I came into the turbulence and I increased this to 40 and swirl size 2, and that was it. I experimented with some disturbance, but I want this to be small scale, so I didn't add any of that fine detail that we get in big explosions. I just used turbulence and dissipation, and that was all I needed to get close enough to my reference. And that was it. It's a very, very simple smoke sim. And then of course, to cache that to disk, I need to bring this up over here, and we need the smoke object, so we can just copy, come here and paste that in here, or I just find it's easier for me to just paste. And all I needed to cache to disk was the density, velocity, and temperature. I didn't end up using the temperature in the render, so you could just delete this if you wanted and just use the density and the velocity for the motion blur. Most of the glowing I just created, I use the sort of glowing that you get in the final render is just coming from the sphere and some lights. But if you want to use the temperature, by all means cache it to disk and you can use it however you want. From there, I'm just processing this, making sure that I've got the min and max values. I'm converting it to VDB. I'm combining the volumes, converting 16-bit flit, and I'm resampling the velocity. Resampling the velocity, the velocity is something that we're not going to see. So we don't need a high-res version of velocity. So with this ticked on, it just means that we're going to have half the amount of voxels, but still more than enough to render our motion blur. Converting to 16-bit float, that's going to save us some disk space. And combining the volumes, if we've got a volume like velocity, which is a vector volume, it's got an X, Y, and Z coordinates. It's going to give us 3 different fields, and by just clicking on combine means that it's going to combine our velocity field into just one. So that's very nice. If you can see that here, you can see we've now got this vel, and you can see it's smaller than our density and temperature. If we were to unresample this would be potentially bigger than these two, and we would have 3 of them without this combined volumes, and we're converting it to VDB because VDB is more efficient than volumes. From there, just a pyro bake, and I barely changed anything. I don't think I changed anything, in fact. I think I just, maybe the color, just set this to white. Let's just see the pyro bake by defaults. Nope, I didn't change anything. I just plugged this in, and that was more than enough for my case. Cool. Cool, so let's add our smoke to our simulations. As you can see now, we've got our melting. We've got a melting bottle, and we've got our smoke. Pretty cool. Let's just double check our domain size, stuff like that. I'm just going to turn this brain off so it doesn't calculate. And you can see on here I've got closed balloon. So this is going to act like a floor. We don't need to add a floor. And plus our smoke is going up anyways. But, you know, I always like to make sure I've got a ground plane and our voxel scale. This is the size of our domain. These are all standard. And that's it. I think, oh, the one thing I think is I think I changed the timescale. Yes. So I increased this by one, I added 0.5. So that just means that because it's small scale, I wanted this smoke to move a lot more like fire, or, you know, make it act like it's sped up. And in order to do that, I just increased this timescale. And that's going to give this more violent look that we see here. So if I were to just flipbook this, you can see this is moving pretty fast. Essentially, it's sped up. And I felt like that speeding this up a bit is going to make it appear to be a smaller scale. You could do the opposite trick by making this, you know, lower. So you could make this like 0.75 or even 0.5. And that's going to make it appear slower, and slower meaning larger scale. So that's something to keep in mind when dialing in the scale of your scene. And then moving over to this last part, which is going to be our liquid. Now, I cheated this a bit. I didn't fill this up with a liquid and then ran a simulation and had my ball displace this and squirt out, because I knew I was going to get volume loss issues. And in order to just do this quickly, so what I decided to do is prepare this geometry that will just render as our liquid. And you can see what we had before is just subdividing this as we had our bottle. I'm transforming this up because we transformed our bottle up for our other simulations. But then what I did is I transformed this actually down. So I know this seems a little bit confusing, but this is scaled up just to match our other simulations. And then I just scaled this down because Vellum Fluids does work pretty well with smaller scales. It's still not real world scale, but I made it a bit smaller. So here I'm preparing that, and what I'm going to do is I'm going to just clip this down. So this is going to animate down like it's losing volume as it gets displaced, and I'm just doing that by hand. So I'm just clipping this and I'm animating this to move down. I'm using a polyfill to fill this up, and then what I'm going to do is I'm going to make an emitter and I'm going to shoot liquid up. And that's going to obviously fly up, and it's going to collide on top of this. So we're going to get all our fluid behavior sitting on top of this. This is essentially just going to work as a collision. And I just found doing it this way, I was able to get the result I was looking for relatively quickly without trying to solve this entire flip simulation or fluid simulation, I should say, Vellum Fluids. So the one thing that we could do is we could create a sphere here, and we could use this match size to move this down with our animation. So if I just template this, you can see that this sphere is moving down. This was one idea I had, but then I thought, instead of doing this, let's delete this because I didn't actually use this. So what I ended up doing is creating this. So here I'm importing this again, animating this down. On this side we have our full liquid, and boolean and subtracting this from this, which is just going to leave us this. I transform this down a bit, so using this expression, means that I can scale around the object. So I've saved this as a preset, and as you can see, look, if the scales around the origin. Without this expression, it's going to scale from here, so that's not what we want. And you can see I've just got this isolated. And then I just wanted a sliver of this. So I'm using this clip. And you can see, so this is where our emission is going to take place. This is going to emit particles. It's going to emit, and then it's going to go down, and it's going to stop. So I'm polyfilling this. So this is, you know, you could use this version, or you could try just using this sphere with this match size. But I ended up using this version. Polyfilling to make sure it's closed. Not using this transform I didn't think is doing anything. And from there, I can convert this into our points using this vellum fluid. Here, I'm going to add some velocity, like we did with the smoke. So just creating some curl noise on this so that it sprays all around. And we're going to feed this into our DOP simulation. We're taking this first input and the second input, which is we're taking this first input and the second input. And if we come over here and we type this expression, this is going to read in this first input, and this is going to read in the second one. So we can just add that there, or we could just copy paste a null like we did in our other simulations. We've got a vellum object. We've got some collisions. So if we take a look at this collision here, let's turn on our brain quick. So here you can see I'm reading in this geometry, and it's the ball and our bottle. So if we come out here, we can see I've prepared that here. So I've just used this transform to transform things down. And so this is just a copy of this. So I think, hang on, and then, yeah, so I just came here and you can say actions, create reference copy, and this is just going to make sure that this node is essentially the same as this one. So if I just copy paste these, you can see that this is now going to have the exact same transform. And here I'm unpacking this, merging these two together. Here I'm creating a geometry. Well, this is our geometry, and here I'm converting it to VDB, and I'm saving that out. So I've got a SDF version and a geometry version, like we always do with our collisions, and that's going to be fed in here. From here, we've got a ground plane, which is going to sit create on the floor. And here we have our vellum solver. And I believe coming out here, I increased the substeps to 10. Let me just see. I think I will say revert to defaults. Yeah. So I've increased this to 10, and it starts on frame 20, because that's when the ball sort of is going to hit the sort of liquid, the cold drink. So these are my settings. I think I added some viscosity and this repulsion weight. I turned this off because I wanted it to, I didn't want the particles to split apart and look too much like droplets. I wanted to keep together as much as possible. So I turned this repulsion weight down, and I also added some viscosity and surface tension. So let's just take a look at those settings. You can see this is only active before frame, between 20 and 100. So after 100, you can see this is 1. And then after frame 100, let's just turn this brain off quickly. After frame 100, it's going to turn off to 0. And that's going to stop the emission there. So here on the viscosity, I just added a little bit of viscosity. I'm not actually sure if this is doing much at all. I think I did play with this value a few times. This is pretty low viscosity. So I'm not sure if this is actually doing anything. And same goes for the surface tension. I did play with these. If I remember correctly, I thought these would have been higher, but turns out not. So it's quite likely that this is actually not actually doing too much, but play with these values and see what you get. But this is my final settings, and looks pretty good. I'm pretty happy with the result. So from there, of course, we have a gravity, and I've increased this by 2. Once again, just because I was messing with the scale a bit, and I wanted this to fall pretty quickly. This is also set to each sub-step. So from there, we're just going to cache this like we did our flip fluids, and you can see, you can change this preset to liquid, and in this case I'm just importing the geometry, surface, and velocity, caching that to disk. And you can see this is what we're getting. You can see our collisions weren't quite working perfectly here. So we're going to take a look at cleaning that up in a moment. But for now, we're just going to visualize this as the velocity of this. So as it moves quickly, we're going to give it this color. And as it's slower, we're going to fade off to here. You can see the collisions here and here are not perfect, but we can easily clean that up. Since this is, this is not a physically accurate simulation, I was just doing this artistically. Here we're deleting everything but the points. So as you can see, this is to make sure that we're just keeping the points, and attribute delete to delete all the attributes I don't need. I just want the the P scale, the position, the viscosity, the velocity, and the color. Delete our groups. And another thing I wanted to do is I wanted to blur the position, and this can make things a little bit more fluid-like. It's also going to shrink things in a bit. It just means that it's basically going to look at all these points, and it's going to average their position. So if we can see here, we can get more of these sort of blobs and liquid sort of effects. And this is really cool looking. To me, it makes things look a little bit more small scale and more mesh, more fluid-like. So you can just see I've set this to proximity, and I'm blurring the position. You can it's too much, but you just need a little bit. Something like that is cool. From there, I can convert these points into VDBs using this VDB from particles. Here, I'm bringing in that mesh, making this a VDB, and I can combine them both. So now as this moves down, we're now replacing that part that we clipped off with our fluid. As you can see, we still have that issue with that those particles landing up here and inside our sphere. So I just cached this to disk so that this would run a bit quicker. And what I'm doing here is I'm bringing in our bottle and our sphere. I'm converting this into a VDB, quite a high resolution. And then I'm using this VDB combine, and I'm computing the difference, which is going to subtract this. It's going to subtract this from this, just like a Boolean. And you can see now we've cleaned this up. And we now have a perfect mesh that's going to fit perfectly within our bottle and our sphere. From there, I'm converting this to polygons, and you can see I don't have any adaptivity. I just decided, you know what, I'm just going to keep this very high res because I want this to match with my geometry as best as possible. I don't want to see any gaps between my fluid and the bottle. So I just kept it. Obviously, moving up your adaptivity is going to optimize things, but like I said, it's going to change the geometry a bit. And then I cache this to disk. cool. And things are moving around a bit here, but we've got that label here, so we are all good. The next thing I want to do is I want to transfer the color and the velocity from our points onto this mesh. So as you can see, we come up here. I'm just going to scatter some points on the surface, mesh those together, put a color on this. So this is going to be our like sort of Coke color. And I'm merging that with our simulation. Here I'm using this particle surface to color this. So we don't need this color here because we're actually computing it here. So all that this node is really doing is it's taking the look at the velocity, computing the length of the velocity, and then it's mapping the length of the velocity to this color ramp. So low velocity is going to have this dark color, mid is going to be around here, and it's going to have a lighter color, and then it's going to go over to this foamy sort of look here. And from there, we've got our attribute transfer once again, and I'm just transferring the color from those points onto our mesh. And so now we've got that color on there. But you can see I want to blur this out, and unfortunately some of these parts are going on the outside of this bottle and landing here. And if we were to blur that, so I'm just going to disable this, and here you can see we're blurring, but now it's blurring the points here, and I don't want that. I only want to blur it up here. So what I can do is I can create this mask. You can see here how this is getting masked off. And what I was doing in here is I was just taking the position, and I want to create a ramp along the height. So I just have to, because the position is a X, Y, Z coordinate, a vector, and I only want the Y component, I put down a vector to float, I take the Y component, and I fit this. And then what I was actually doing at first, so let's just take a look here. I would visualize this. So here you can see if I export this as color, then I can tweak this and I can find my area I want to mask. So something like that. And then instead of exporting this as color, I export this as a mask, and I label it height mask. So I just put down a bind export, and I could call this whatever I want. In this case, I called it height mask. And then on my blur node, I can just say length weight, and I blur, you know, I use this mask basically. So it's only going to blur where our height mask has a value, a high value. So you know, we visualize that high value as white, and where it wasn't white as black. And so now it's going to do exactly that. It's going to only blur where we have that white value. And so this works pretty well. So I mean, in Houdini, a lot of the time all we're doing is transferring attributes, and we're creating masks. So I think this is like a really good example of how to control things in Houdini as simply as possible. And if you keep those concepts simple, you can scale up on them. So for instance, like take a look at the tutorial I did on a volcano scene, and it can be pretty complicated, and there's lots of vex in there, but all we're doing for the most part is transferring attributes and creating masks. So I created this scene to keep that concept in mind, but keep it as simple as possible. So yeah, I'm using that attribute transfer, and here we're showing an example of masking, and I'm going to then cache this out to disk again. And using this transform, we can click on invert transformations. So previously you can see this is all grayed out, and that's because I had come here, clicked create reference copy. And then what I did is I said on here, delete channels. So now this is no longer part of the copy. And then I can just click invert. And I can put that enel out and add this to our simulations. Pressing F on my keyboard. And you can now see we have our liquid, our bottle melting, our sphere, and our smoke. And that is that for our simulations. Next, we'll take a look at how to render this. So we want to take a look at the rendering section now. So what we do is we come up to this build and we change this to Solaris. And now we're in the Solaris view. And if I come over here, and if I come over here and I come over to stage, we can see this is our rendering setup. And I'm just using this SOP import to import the bottle, and we're reading in the null. So all we need to do is come over here, take this null, copy it, come over to stage and paste that in there. So that's going to read in our SOP geometry. Here we have this ball, and the reason I've got this render geometry settings here is because I want this to emit light. And so if I come down here to this treats as light, this would be normally grayed out like this, but you click this and say set or create, and that's exactly what I've done here. So let me just redo this quickly. Render geometry settings, and what I did was under Karma, under light, and click here, say set and create, and treats as light. And we need to set up a shader for this to work, but that's what we're doing for this, our sphere. We're bringing in our smoke, we're bringing in our fluid, our label, and here I'm just creating a stage. So instead of using a SOP import, here I'm just creating a SOP create, and I've got a grid. And I want to select some points. So what I would have done is come in here to what I did. So I came over here, set this to top view, and I just grouped these top 9 points, and I typed soft transform. And as you can see, this creates our selection. And what I would have done is just transform this up and increased this fall off. So now we have this slope. That's exactly what I did here. My exact settings are like this. Could increase this even more potentially. And I just transformed this up, and I set a color. So here is our setup. We've just imported all our geometry, and here we're going to create some materials. So diving into this material library, I'm not using this, but I'm using this ball. So here we're going to create a noise. And if you wanted to visualize this, you could just put this, you know, while I'm working on this, I don't visualize it as a mission. I take this out and I go into base color. So for now, I just want to show you how I did this. So this is how I would tweak my settings by just checking it like this. But in this case, you know, I'm just taking a noise and I am multiplying it like so and feeding it into the emission. So I now get something like this. For my fluid, I'm taking the geometry color. So let's just go and take a look at our fluid. And let's come over to where it splashes. And you can see, so remember we have this color on our liquid. Come over to SOPs. You can see we've got this, you know, this dark cola color and then going to this lighter foam. And what I did is I used that ramp, that color ramp. So I wanted to import the color. So I'm feeding this color into the base color, and then under transmission you can see I've pulled pulled this down and I'm giving it this color and the scatter. The index of refraction is 1.9 and the specularity is 0.4, roughness turned down to 0. And that is giving us this look that we see here. And on the plastic, so let's go over and just take a look at our plastic, which is what we see here. And we can see this is transparent, but as it melts, we're getting that sort of caramelly burnt plastic look. And what I did there is I took again the color and I pushed this into the transmission color and the transmission depth. We can ignore this, and on our settings it's the same. Roughness I've turned up just a touch. Index of refractions is pretty much similar to our liquid, and this is giving us this plasticky look. Let's see what happens if we turn this down. Yeah, okay, so that's our settings. Transmission 1, but like I said, this color is coming from here and the depth, and this is prepared on our geometry. So if we take a look at our geometry once again and we come over to our multi, you can see it's white where it's transparent, and then it's got this sort of burnt caramel color, and that's our result. Our smoke is very simple. I'm not really doing anything shaded. It's just being pulled directly from that pyro bake. So no need to even set up a shader for this. It's literally just coming straight from the pyro bake. And our label, as you can see, I just read in a texture. So just an image, and it's going into the base color. That's it. Nothing special whatsoever. And our geometry that doesn't have a shader is literally just this base color, and we can read that in and it looks fine. Of course, you guys can tweak this. This label maybe needs a bit of work, but you can see how just a really quick, simple setup, and I think we got something quite effective. We'd need a material sign, obviously, and as you can see, I just come over here, I drag my ball, and that goes here, and the shader that comes over here. So I'm just assigning it by dragging and dropping these. I'm importing the scene cameras from SOPs, so that will pull in my camera. And then as for lights, here I've got a point light which is being illuminated here. Sorry, this is a distant light. This is backlighting this. If I come and take a look through here, light 5, I'm just pointing down. Light 3, and you can see I'm putting on normalized power, and I like to color the temperature with this here. So this is the one that I'm placing inside the smoke here. And I think what I did is I just came here, yeah, and I set the diffuse, and I just clicked on my sphere to place the light. And I think I may have even reduced the distance to something very close like this. Yeah. So that's where that illumination is coming from. Let's enable it. Come over to our next light, and you can see this is just a light, side light that's going to hit this label. And this one from the other side. And this is my HDRI. And I'm just bringing in this artist workshop. This is something from HDRI Haven. And it's turned down to 0.8. Enable these two. Now we can get our smoke in there nicely. I've added another camera, and these are my comma settings. So this is where it's going to write out to disk. This is my resolution, my samples, my limits, camera effects. I have motion blur turned on because I wanted to capture the motion blur of these moving. I'm making sure that my color space is set to Aces CG here. Without this, it's going to export the wrong color space, so make sure you have this. And then I've got the beauty, and I'm splitting per light. I've got the diffuse, the indirect, the direct glossy, indirect glossy, direct emission, indirect emission, albedo, the position for the world space, the depth, the normals, and that's it. And then my ROP. Cool, and that's it. I rendered this out, and then I did some very basic tweaks in Nuke. You know, just a little bit of chromatic aberration, not really much, and composited the background into this. So yeah, thanks for watching everyone. I hope you learned something, and see you in the next one. Okay, bye.